Lesson 3 is on solving quadratic equations by completing the square, which is a skill that you learned in the first unit, quadratic functions. So hopefully this lesson will solidify your skills in completing the square. We're going to start with a little review here, simplifying a radical from 10C. So to simplify radicals, and we're just going to break them down into factors, at least one of which is a perfect square. So the first thing we do is write down all the perfect squares. For example, 1 squared is 1. Oopsie. 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. 25, 36, 49, 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, and we'll stop there at 15 squared is 225. So for this first example, root 20, we want to find two or three numbers, I guess, which will multiply to get 20, one of which is in this list. And you can probably clearly see that it's going to be 4 times 5. So we're going to break root 20 down into root 4 times root 5. Now, really, it's 4 times 5, but we know that anytime you've got two numbers under a square root sign, or any root sign, and then multiply together, you can look at them individually as roots. So that's why I write it like this. The square root of 4 is 2. And that's our answer, because you can't break down 5 any more than that. All right, let's go to the next one, 50. 50. Anything here, anything strikes, anything that you see looks good? Oh, this looks good to me. That looks good there. So we can break root 50 down into 25 times 2. The square root of 25 is 5. The square root of 2 is just root 2. And so that's done. 108. 108 is a little more challenging, but not too bad. You can probably figure out after a minute or two of looking at it, or less, that 36 times 3 is 108. Six root 3. That is the answer to that. Okay, let's move on after the lovely music finishes. There it is. And now, so we're going to start with not completing the square, with some other principles of square roots. And in this example, first example, it says solve the following equations, state the answer as exact solutions, which means no decimals. You leave things in root form. The first one is the square root of x equals 16. So we don't need to complete the square for this necessarily. We could if we wanted. It would just be overkill. All we need to do on this one is take the square roots of both sides, because we want to find x, not x squared. So we take the square root of x squared, and whatever you do to one side, you got to do to the other side. So square root of 16. And the square root of x squared is x. And it's actually plus or minus x. And the square root of 16 is 4, but big note here, big note. Remember to take the positive and negative possibilities. So this should be plus or minus 4. Okay, and now if you're an inquisitive person at this point, you can say, well, why didn't you take the plus or minus of the x? And yes, absolutely, I should. It really should be, I'm just going to write this up here. It really should be plus or minus x equals plus or minus, plus or minus 4. But if then I apply all those solutions, two of them cancel out anyway. So for example, let's go back down here. This is going to be x equals 4 and x equals negative 4. Those are my two solutions. These are kind of all the solutions. But if I did this, if I said, okay, well, also negative x equals 4 and negative x equals negative 4, those two produce the same solutions. So what I would do here is I would say, oh, I don't like the negative, so I'm going to multiply both sides by negative 1, and then I'm just going to get x equals negative 4, which I already have right down here. And then for this one, same thing. I'd multiply both sides by negative 1, and I would get 1 there, and I would get x equals positive 4, which again I already have. So you don't need to do both plus or minuses, because two of them will always cancel the other two. I'll not cancel them out, they'll always be redundant. So that is why we only need to take the plus or minus of one side. All right, moving on. Square, let's shorten things up because this is really easy. Square root of this, square root of that, x equals 7 does not have a perfect root, so you just leave it. That's it. That's the answer. That's all you have to do for that one. This one, we can do one of a couple of ways. The easiest thing to do for this one is we could take the square root of both of them right away if we wanted, because they both have perfect roots. 4 has a perfect root, x squared has a perfect root, and 36 has a perfect root. The other thing that you can do, though, to simplify first, is just divide both sides by 4, giving you x squared equals 9, and then apply your square root principle. That's what this is called, incidentally. And you get that. If you just applied the square root principle right away, right from here, then you take the square root of that and the square root of that, and you'd get 2x equals plus or minus 6, and then you would divide both sides by 2 and end up getting exactly the same answer. And the last one here, x minus 5. Just going to check how much time. We're 7 minutes in. X minus 5. We're going to take the 5 over to the other side, apply the square root principle. X equals plus or minus the square root of 5. So those are your most basic ones. Now they get a little more involved for these ones. So, actually this one's pretty straightforward. It's exactly the same, except it's got a little quirk to it. So this, we're going to take the 25 over to the other side, and then we're going to say x equals plus or minus the square root of negative 25. Now this is an issue for us at a high school level, because we can't take the square root of a negative number. There's no number times itself which equals negative 25. Because a negative times a negative is a positive, and a positive times a positive is a positive. So the answer to this is there are no solutions. But that's not really the answer. If you get onto some university level math, you will probably study the complex number system. And in the complex number system, this is something you don't need to know, so you can close your ears or plug your ears if you don't want to hear this. In the complex number system, we have imaginary numbers. And the most famous imaginary number is the square root. I'm just going to do it over here, and then I'm going to erase it. Is the square root of negative 1 is called I for imaginary. And so the solution to this, so what you would do in the university level is you would write negative 25 as 25 times negative 1, square root, and then this would be plus or minus 5, and then the square root of negative 1 is I. So that's your actual answer to this question at a university level. We actually used to teach this in high school, but we don't anymore. But just in case you're curious, that's how you would solve it in university. Okay, you don't need to know that though. So let's move on to the next one. Oops, invaded the space there. Here, square root, square root. right? There's no point in multiplying this binomial out by itself, right? It'll just complicate things. So square root, square root. The square root of x plus 1, x minus 1 squared is x minus 1, plus or minus 3, and therefore x equals 3 plus 1, which equals 4, and x equals negative 3 plus 1, which equals negative 2. So there are your solutions right there, 4 and negative 2. Okay, same thing for this, for g. Let's just do that one really quickly. G is just going to be, take the square root, x plus 1 equals plus or minus root 5. Therefore, x equals root 5 minus 1, and x equals negative root 5 minus 1. Those are your two solutions for this question here. And the same thing with our last example. Square root, x plus a quarter equals plus or minus 1. X therefore equals 1 minus a quarter, which equals 3/4, and x equals negative 1 minus a quarter, which equals negative 5/4. Okay. All right, let's go on to solving by completing the square. So when are we going to resort to completing the square, which we all know from quadratic functions is quite a complex little beast? We are going to do that when it is not possible to do what we just did in those other examples. So let's just go right onto the example so this lesson isn't too long. And here we go. We look at this example here, A, and we say to ourselves, well, first of all, it's a trinomial. So we can't just do this. You can't just say, oh, the square root of that, the square root of that, because you're dead in the water at this point. You can't simplify this at all. So that's a no-go. That is a no-go. So what are we going to do? We are going to complete the square exactly the same way we did in quadratic functions. So this is a great review. Here we go. First thing, get the constant over to the other side. X squared plus 8x equals negative 11. Step 2, turn this part into a perfect square trinomial by taking the term that's the coefficient of x, dividing it by 2 equals 4, and squaring the answer. 4 squared equals 16. And once again, I always do it in these kind of 2 steps, even though you could do it in 1, because this number here turns out to be the answer. Right? So, or part of the answer, let's say. So turn it into a perfect square trinomial by adding 16 to both sides of the equation. Add 16 equals negative 11 plus 16. Now at this point, we've created a perfect square trinomial right here. There it is. And what do? We factor that perfect square trinomial. And if you've done it correctly, it's always going to work out to be an easy factoring, because you're going to take the square root of that, the square root of that, right there, right there, right there. Ooh, let's get blue. Right there. That's why I say that's part of the answer has been given to you right there. And the sign of this. So that's a plus, brackets around it, right squared. That's how we factor perfect square trinomials equals positive 5. And from this point, it's very similar to the examples that we've just done. Take the square root of both sides, square root, x plus 4 equals plus or minus root 5, and then move the 4 to the other side. X equals, and we'll just write the solutions right away since we've practiced this a bit. equals positive root 5 minus 4, and x equals negative root 5 minus 4. Those are our solutions. Okay. I think we can kind of just to make the video a little shorter, we'll skip example B. Example B is very similar to example A. And let's go on to C. C, because there's a little quirk in C that we need to be aware of. Once again, the first thing we're going to do is move the constant over to the other side. Equals positive 1. Now at this point, you can see that, again, we need to turn it into a perfect square trinomial. The problem is that the x squared term has a coefficient, but that coefficient happens to be common to both terms. So at this point, you can just factor out the 2. Don't factor out 2x, even though that's common to both terms. You could actually, I would actually make it simpler if you factor out the 2x, because then you could just use you could just set each one equal to 0. But just for the practice of completing the square, let's do it this way. So you can factor that out and then proceed as normal. Right? Take this, turn this into a perfect square trinomial. Take 3, divide it by 2, giving you 3 over 2, and then square that answer, and that gives you 9 over 4. So we're going to add 9 over 4 here, equals 1. And we're going to add, careful here, 2 times 9 over 4 to this side. So don't forget to do that, which essentially equals 18 over 4. Then leave the 2 out there. Back to the trinomial, square root of this, square root of that, which is right there, sine of this, squared equals, and 1 plus 8 plus 2 times 9 over 4 is actually 11 over 2. You can check that on your calculator if you want to. And at this point, the square root principle. No, not the square root principle at this point, because this 2 is kind of getting in our way. So actually, we can divide both sides by 2. Divide by 2. Those will cancel, leaving us with x minus 3 over 2 squared equals 11 over 2 divided by 2 is 11 over 4. Why? Because 11 divided by 2 is the same as 11 over 2 times the reciprocal of 2, which is 11 over 4. Now you can take the square root of both sides. Square root, 3 over 2, plus or minus. Now here's where we get into the little kind of nitty-gritty of things. Plus or minus the square root of 11 over 4. Let's just write it like that for now. But 4 does have a perfect root. So you can actually write that as plus or minus root 11 over 2. And that's kind of nice, because now when I move this 3 over 2 over to this side, I'm going to skip that over there, I'm going to get x equals plus or minus 11 over 2 plus 3 over 2. And I have a common denominator, and the way that we'll usually write the answer to this question is as follows. Even though this way is totally correct. You get 100% for that answer. But if we want to simplify it as much as possible, we just like to write it like x plus or minus root 11 plus 3 all over a common denominator of 2. So that's the most common way to write that solution. Okay, I think again we'll skip example, no, how's that? Example D. D will skip. You can do that by yourself because it's very similar to C. And that's it. That's it for the entire lesson. So hopefully you got a lot out of that or you understood it. If not, rewatch it. And we'll see you for lesson 4.